Okay, so 2.1, the derivative and tangent line problem. We're going to be finding the tangent line today. So this isn't something you need to write down. This is what we're going to be doing. Calculus grew out of 4 major problems that European mathematicians were working on during the 17th century. The tangent line problem is in 1.1. We have the velocity and acceleration problems we will discuss in 2.2 and 2.3. It's important to know velocity and acceleration, correct? Mm-hmm. Those are important things. Minimum and maximum problem. Would it not be important to know the maximum of our sales or the minimum we need to make to cut a profit?
Minimum, not important.
The minimum we need to make to cut a profit?
Oh, I thought it was not.
I don't know what any of that means, honestly.
The maximum.
You don't know what maximizing sales means or minimizing? Like, I have to sell at least 5 to break even. Wouldn't that be important to know on a company?
Maybe.
It's like not being the whole.
You make a profit?
Money back.
Okay, anyway. The area problem, we need to discuss. It's important to maximize area, minimize area. That happens a lot in building, farming, about everything. Each problem involves the notion of limits in calculus, which introduced with any of these 4 problems. So you don't need to write this down again. We're just going to look at it, okay? We've got some things going on. Go back. Okay, on these problems, do they have a constant rate of change? Do they have a constant slope, any of them?
No, they're not.
No. Okay, so we can, on this first one, we could find the rate of change up here, couldn't we?
Yeah.
Yes. But if I want the rate of change right here, is it the same?
No.
Or right here?
Uh-uh.
No. So are these rate of change, are these slopes, quotation marks, the same?
No.
No. They change, correct? We need to find the instantaneous rate of change. That's what we're working
What
towards.
changes it instantly?
Yes, the instantaneous rate of change. So we're not going to go through this whole exploration. I decided, but I just wanted to show you why we need this. The world is not linear. Until like algebra 2, the whole world was linear, and then algebra 2, everything was a parabola, right? Mm-hmm. Some absolute values in there. And then last year we had absolute values and trigonometric and involving more. The world is not linear. And so we need to deal with the world, and that's why calculus is here to do that. Okay, so we want slope, yes? We want rate of change, we want slope. So one way we can do that is to draw a secant line between 2 points. A secant line is a line that intersects an object, guess how many times? Twice. A tangent intersects an object how many times? Once. Okay? Those are what they are. So we have the slope between C and f of C, and then C plus the change of x, just moving it over on the x-axis, correct? And then plugging that in. Isn't slope y2 minus y1 over x2 minus x1? Do not write this down. I want you guys to follow. This is not something that's going to help you.
Oh, I was writing that the secant intersects 2 times.
Okay, that's fine. But I don't want you to write this down. I want you to watch through. Okay, so I have slope, yes?
Yes.
Okay, so I have 2 points over here. Do you see my 2 points? Right here and where?
Underneath.
Right there.
Yeah. Oh.
I got those 2 points, yes? Everyone following?
Uh-huh.
Yes.
Okay, I want none of this written down. I want you to watch. Okay, so y2 minus y1. y2 is right there, isn't it?
Uh-huh.
So I have f of c plus the change of x minus y1, which is
F of C.
F
How
of
do you know
C.
which one's the first one?
It doesn't matter.
Oh, it doesn't?
Well, you always do the second one as the furthest one right.
Okay.
But it really, honestly doesn't matter. Okay, so we have that. That's just, this right here is just from the slope formula, isn't it?
Mm-hmm.
Okay, so now we need x2 minus x1. So x2 is
C plus
C plus the change of x. x1 is
C.
C. So if I simplify, the c minus c is 0, yes? So I simplify it to this. So the slope m of the, what does SEC stand for? Secant line. The slope of the secant line is the function with f plus change of x, in for x, yes? Minus f of c over the change of x. You need to write this down.
Okay.
But I wanted you to see how we got that formula. You don't need to develop it. You need, just write it down.
So we will need this formula.
You will need that formula. You use it every single problem today. You use it every single problem the rest of the week.
The
No,
rest of our lives.
no, today and tomorrow at least. This is known as, not only the slope of the secant line, is also known as the difference quotient.
But it is the slope of.
The slope of the secant line is the difference quotient. So you need to know that because the directions may say use the difference quotient. So what are they asking you to use?
Slope of the secant line.
Right. The slope of the secant line is the same as saying the difference quotient. Because did we not just find the difference of the y's over the difference of the x's?
Yeah.
Yes, that's why it's called the difference quotient. Now while you read, I'm going to read you a side note. In 1637, mathematician René Descartes stated this about the tangent line problem. And I dare to say that this is not only the most useful and general problem in geometry that I know, but even that I ever desire to know.
Oh my.
It is honestly, it's the most important thing to solve. What is the rate of change right now? Okay, right now. Now, I can get an average between these 2 points, correct? By doing this?
Mm-hmm.
I can get the slope of this line right here. What happens as those points get closer and closer together? What am I nearing? Not a secant line, but a what?
Tangent.
Tangent.
Yes.
Okay? So as those change closer and closer and closer, I'm not going to get the slope of a
Because they only
secant.
pass through the line once.
Right, when it gets there. So that's why they just use change of x's, because those are going to be different.
I'm slowly remembered like doing this stuff in like physics, I think.
Yes,
maybe.
yes.
Oh, I
That would be-
should have taken physics.
Okay, so right here, now, this should look familiar. Yes?
Yeah.
That's what it was.
Okay, we just up there, but what did I change?
Then
The limit. Now, again, I'm going to go back. What did I just say? As these points get what?
Closer and closer.
Closer and closer and closer. So the difference between them would get
Is
closer and
the
closer
limit.
to
zero.
0. Okay? So this equation, the slope of a tangent line, this is what you're going to be doing on all 6 problems today. The definition of a slope of a tangent line is the limit. I would just write this part right here.
Okay.
Always forget to do that. The slope of the tangent line is right there. The limit as the change of x becomes 0. Did I just not show you that on that other graph? Those points are getting closer and closer to what? Together, right? So the limit as the change of x approaches 0 of the difference quotient. F of c plus change of x minus f of c over the change of x. That equals the slope of the what?
The tangent. No.
Yes, the tangent line. Okay? The slope of the tangent line is the limit as the change of x approaches 0 of the difference quotient. We actually manipulated that different quotient a couple times last year, different times throughout the year. The slope of the tangent line to the graph of f at the point C of f of c is also called the slope of the graph at x equals c. Just, it's the slope of the what?
Tangent line.
Tangent line. So the only thing you need on your paper is the slope of the tangent line and that underlined in blue. Got me?
Yep.
That's what you're going to be doing on all 6 problems today. That one good?
Yeah. Yes.
Okay, so we need to find the slope of the graph f of x equals 2x minus 3 at the point 2, 1. So we first need to find the slope of the tangent line. Now this is a very easy problem, and when we do it, you're going to be like, really, duh. Okay. So I need to use this formula. You guys are ready to use the formula?
Yeah.
Okay. So we have the limit of the change of x as x approaches 0 of f of c plus change of x. So that means I write c plus the change of x in for x, yes? So 2 times, well, what's x now?
2. No.
No,
C plus the change of x.
c plus the change of x. We're doing composition of functions. See that? Minus 3. This says f of this. So x turns into what? Because this is f of x, right?
I see.
So I did the first part. Minus
3.
f of c. So what's x going to turn into?
3.
No, minus 3. This was the first part already. We're done with it. We need the second part now. Minus f of c. Now what do we change x into? What are we changing x into?
The C.
The c.
I don't understand that though.
This is composition of functions. So 2c minus 3.
Pretty sure Isaac's doing this, but like way
Oh.
harder.
All over what?
Change of x.
Change of x.
That doesn't change though.
No. So we're done with the calculus. Now we have to simplify it. We have to do our algebra. So how do we simplify that? We still have the limit going on. I guess we're not done with the calculus, but we're done for right now.
I'm going
Distribute the
to,
two.
yeah, distribute
Distribute the 2 and
the negative
the
3,
negative. So you should get,
a positive.
Wait.
everyone do it.
Okay.
Okay, so did you all get 2c plus 2 change of x minus 3 minus 2c plus 3?
I thought the first
Kinda.
chunk, but then after the 3, it goes downhill fast.
Okay, you got to distribute that negative.
Got it.
So now
Get
what?
rid of the 2c.
The 2c 0 out.
Combine the 3's to 0 them out.
0 those out.
Okay, they 0 out.
We have 2
So we have
change of x
C plus
over
C
change of x.
the limit, not divided by. The limit as change of x approaches 0 of 2 over the change of x, 2 change of x over the change of x. Now how can I simplify that?
You can, it's just 2.
It's just 2. So I have the limit of the change of x as x approaches 0 of 2, which is what?
2.
2. Now, guys, this is a linear function. What's the slope?
Um,
0.
Y equals mx plus b, yes?
Yes.
The slope is what?
oh,
2.
Why?
Because
That was
that's a
really
linear
embarrassing.
function, and that's what the slope is the coefficient of x, correct?
Really embarrassing
Oh.
for me too.
Okay, so now at the point 2, 1. So if I had an equation, would I plug 2 in for x and find the slope? Yes, but do I have an equation? No, I just have 2. Okay? So now let's do it again. Not with a linear function. Okay, so I think I put the equation again.
This is so much.
Okay, so remember, and I'm going to stop before we start doing this, guys. This is composition of function. This is f of c plus the change of x. So that means c plus the change of x goes in every time you see x, correct? Correct?
Yes.
Yes.
Can we try this one on our own?
Yep, you do it on your own and I'll do it on mine. Just don't look up.
Wait, I've got to write the problem. Can you wait?
Okay. I'm just doing this part. Worry about the slope of the tangent line for this second. And then we'll worry about the slope after we get that, okay? Can I start now?
No.
Yes. Oh.
What are you still writing?
The problem?
This is the only problem.
Yeah. I write the whole thing. You know? This is, okay. This is still secant, right?
No, we're finding the slope of the tangent line.
How do we know?
Because it says find the slope at the given points. Just do this.
Oh, because it gives us 2 points?
No, just do this.
How do we know it's tangent?
Because we want the slope at a certain point. That's the tangent, hitting one time.
But that was the
Just.
Was the last one?
Just do the problem, yes. Just do the problem exactly how we just did. Every single problem, you're going to be doing this formula. Because you're going to find the slope of the tangent line.
Oh, I'm confused. You can do it. Oh, that makes sense. Okay, why are you putting negative after?
Because it's the formula right there.
Oh, duh. Sorry.
That's okay.
Dumb question. Why? Oh, that's a really dumb question.
Okay, so I need to know, can everyone do this? Plug this in. Can everyone
Hold
get
up.
the first step?
Yes.
Yes.
Yeah, I think I can. Yeah, I'm for sure can.
Okay. Question.
So when you go to cross stuff out in step 2,
Mm-hmm.
how are you doing that?
Well, I have a
Because-
positive c squared and a negative c squared, so that's 0. I have a positive 1 and a negative 1, so that's 0.
Okay.
Okay? So step 2, I just reduced out what's zeroed out. Step 3, I just rewrote it. Step 4, what did I do?
Canceled this out.
Well, I factored out a change of x. Because remember, this is a quantity, and so unless I can factor it, I can't reduce it, can I?
Mm-mm.
So I factored out a change of x, and then I reduced my change of x's. And I'm left with the limit as the change of x approaches 0 of 2c plus change of x. Well, how do I find that limit? I do direct substitution, yes? Correct?
Yeah.
The limit as the change of x approaches 0 of 2c plus the change of x is 2c plus 0, which is what? 2c?
How do we know the change of x is 0?
Because it says it approaches 0. Yes?
Yeah.
Okay, now, this right here is your slope function.
I'm so confused.
This is your slope function. But I'm not going to use c anymore. I'm going to change the c to a guess what?
X.
An x. So now I have 2 points, yes? If I want the slope at 0, 1, I'm just going to do what? What am I going to plug into 2x?
X.
What is the x?
0.
0. So it is
Slope at
2 times 0, which is what?
0.
0. If I want the slope at negative 1, 2, 2 times what?
Negative 1.
Negative 1, which is?
Negative 2.
Which is negative 2. So what you're doing today is that 6 problems are to get used to doing this. Got it?
Yes, ma'am.
If you're not getting the slope, if you're not getting this part out of it, we will keep working on that. What is my goal today?
We can do the first step.
This step.
The first.
No, this, everything's circled. Okay, obviously you want to get through the first step, but that's the goal of those.
Hey,
Where
girl.
we're going to be
We're going to be working on it and working on it.
tangent line all day.
Yes.
Not secant line.
Nope, not sequence. Tangent. Got it? You're going to use this on every single problem today.
Yay.
So tomorrow when you come in, you should probably know it already, huh?
Does the bell ring at 30? 1.
And actually, we got all the way through the notes. Look at that. Look at this. Look at this new function you learn tomorrow. Is there any difference between that one and this one?
Yes.
What?
I don't know. It looks
No.
way different.
What's the only different?
F of x is equal to
It's-
the limit.
What's right here? It's not a C, it's a what?
F.
No, it's not a C, it's a what?
X.
X. And what did I tell you to change your C to, the last problem? An X.
You did?
Yep. At the very end, we had 2C. And I told you to change it.